Imagine being told that almost everything you think you know about the universe is based on just 5% of what actually exists. 5%! That's the cosmic equivalent of trying to understand an entire ocean while studying a single cup of water. Yet that tiny sliver, the matter we can see, touch, and detect, is all our telescopes have ever shown us. The other 95%, that's the part the universe keeps hidden behind the curtain. And a huge chunk of that hidden world is something we call dark matter, an invisible force shaping everything from galaxies to the structure of the universe itself. Now, dark matter might sound like something created by a sci-fi writer on a caffeine high. But the name isn't meant to be dramatic. It's dark simply because we can't see it. We can't shine light on it, can't detect it directly, and can't grab a handful of it, no matter how hard we try. In fact, dark matter doesn't interact with light at all. It's basically the champion of hide and seek, permanently invisible, totally silent, yet constantly influencing everything. So the natural question is, if we can't see dark matter, how do we know it exists? Well, the universe is generous with clues, and once you start noticing them, the mystery becomes impossible to ignore. Let's start with galaxies. These giant spinning islands of stars behave in a way that should be physically impossible. Based on what we can see, galaxies rotate far too quickly. The stars at the outer edges should be flung out into deep space, like someone taking a corner way too fast in a tiny car. But the stars stay, calmly orbiting as if nothing is wrong. It's one of the longest-running cosmic magic tricks. This puzzle caught the attention of astronomer Vera Rubin, whose work completely reshaped modern astrophysics. Rubin studied how fast stars move around the centers of galaxies and discovered a strange pattern. The rotation speeds didn't slow down with distance like they should. They stayed flat, meaning stars far from the galactic center were moving way too fast to be held in place by visible matter alone. Rubin didn't try to force the universe to fit her expectations. She listened to what the universe was trying to say. And the universe whispered, "There's more here than you can see." That more turned out to be an enormous halo of invisible mass surrounding every galaxy. Imagine galaxies as tiny glowing coins floating in enormous invisible bubbles. Those bubbles are made of dark matter, and they're far bigger than the galaxies inside them. But galaxies are only the beginning of the story. One of the strongest pieces of evidence for dark matter comes from something called gravitational lensing, a phenomenon predicted by Einstein. When light from a distant galaxy passes by a massive object, the gravity from that object bends the light, like a cosmic magnifying glass. It's one of the universe's most elegant tricks. Now, when astronomers looked at clusters of galaxies using gravitational lensing, they saw something shocking. The amount of bending was much stronger than visible matter alone could explain. Something heavy, very heavy, was warping space, even though nothing appeared to be there. That nothing was dark matter. And then comes the bullet cluster, arguably the most dramatic evidence we have. Picture two galaxy clusters crashing into each other at incredible speeds. The visible matter, mainly gas, collided and slowed down. But the gravitational mass? That moved straight through, unaffected. When scientists created a map of the mass using gravitational lensing, they found the gravity was centered not where the visible matter was, but where the invisible matter had passed through untouched. It was like watching two ghosts walk through a crowd while the crowd bumps into itself. This is one of those rare, case-closed moments in astrophysics. Whatever dark matter is, it behaves differently from ordinary matter in a way that is extremely hard to dismiss. Now, let's zoom out, way out. The entire universe is woven into an enormous structure known as the cosmic web. Galaxies are not scattered randomly. They form filaments and clusters connected by vast stretches of dark matter. Supercomputer simulations show that if you take a young universe, sprinkle in dark matter, and let gravity do its work, you naturally get the same web-like pattern we see in real observations. Dark matter is literally the scaffolding of the cosmos. Without it, the universe wouldn't have the time or density to form galaxies at all. We'd be living in a much duller, far emptier universe. No spirals, no clusters, no dramatic cosmic landscapes. It would be a sad, lonely place where gravity just shrugs and gives up. But here's the part that drives scientists absolutely wild. Even though we have all this evidence for dark matter's existence, we still don't know what dark matter actually is. We have theories, of course. Entire branches of physics built around trying to explain this invisible backbone of the universe. And at the top of the suspect list, we have some very strange candidates. WIMPs, weakly interacting massive particles. Despite their name, WIMPs are not weak at all. In fact, they might be the undisputed heavyweight champions of the cosmos. They would be massive, abundant, and powerful enough in numbers to sculpt galaxies. Yet so shy that they barely interact with anything. They slip through planets, stars, and your body like they aren't even there. For a particle that could make up most of the universe, WIMPs are suspiciously good at hiding. Then we have axions, ultra-light particles so delicate they behave more like a cosmic field than individual specks of matter. If axions are real, trillions of them would be passing through you every second. No sensation, no sound, no glow. Just an endless, invisible river of particles streaming through the universe and through you, completely unnoticed. And of course, there are sterile neutrinos, hypothetical cousins of neutrinos that don't even bother interacting through the weak force. They're like the ghost version of a ghost particle. If regular neutrinos are already notoriously hard to detect, sterile neutrinos would be the ultimate escape artists. Because these particles barely interact with anything, hunting for them is a monumental challenge. Physicists have built gigantic detectors deep underground, hidden away from the noise of cosmic rays and radiation. Some sit inside abandoned gold mines, others are embedded inside mountains. These detectors, sometimes swimming pool-sized tanks filled with ultra-pure liquid, are designed to wait patiently for a single, impossibly rare moment. A dark matter particle gently bumping into an atom. And so far, nothing. Not even a polite cosmic nudge, just silence. But silence doesn't mean failure. In science, ruling out possibilities is progress. Every experiment tells us which suspects are innocent and which ones are worth interrogating further. It's slow, careful detective work, but it is leading us somewhere. Some researchers take the mystery even further. They argue that the problem might not lie with matter at all, but with our understanding of gravity. Maybe gravity behaves differently on cosmic scales. Maybe Einstein's equations, brilliant as they are, need a microscopic adjustment. It wouldn't be the first time physics has undergone a revolutionary rewrite after a new discovery. And then there are the truly exotic ideas. a whole dark sector of particles with their own forces, their own interactions, maybe even their own structures, forming a hidden version of the universe next to ours. Some theories even propose extra dimensions curled up in ways we cannot detect. If any of this is correct, dark matter wouldn't just be a missing puzzle piece, it would be the entrance to an entirely new layer of reality. Because the universe is not shy about surprising us, every time we think we understand its rules, it reveals a twist. But here's the part I find incredible. Whatever dark matter truly is, the moment we discover it, will unlock a new chapter in physics. It could reveal new forces, new particles, or new dimensions. It would reshape everything from how galaxies form to how the universe was born, and where it might be heading billions of years from now. So the next time you look up at the night sky, remember, the stars, the galaxies, the glowing nebulae, these are just the visible ornaments. The real structure of the universe, the scaffolding that holds everything together, is made of something completely invisible, something we still don't understand. We are living inside a cosmic mystery so vast that our senses barely register it. Yet this mystery controls the formation of galaxies, the clustering of matter, and perhaps even the ultimate fate of the cosmos. And one day, maybe sooner than we expect, someone will finally crack the code. And when that moment comes, the universe will be forced to reveal the part of its story it has been hiding from us since the beginning. If you enjoyed this story, hit that like button and subscribe so you never miss another half-week story. New episodes drop every Wednesday and Saturday. Thanks for watching. See you in the next one.